Continuing on with number 12, I was interrupted. So this time we want to solve, first of all, for this highlighted section, so we would just add 1 to both sides. I think I can do that in my head. E to the 7.5m equals 96 plus 1 is 97. And since this is e, we can just go ahead and change the log form, log base e, which is just natural log. It's the shortcut for that, of 97 equals 7.5m. Same idea here. We could just divide by 7.5m, and we would get, sorry, by 7.5 and get an exact answer. So that's kind of what I did over here with the arrow earlier in the other one. So we would get m is equal to natural log of 97 over 7.5. Or we could have put this in our calculator, so we could do natural log of 97, which is 4.5747. 4.5747 equals 7.5m, and then divide both sides by 7.5. Which gives us 0.60996. So I just left the non-rounded answer in my calculator, 0.60996. The reason I'm writing that is it says nearest 10,000th. So tenths, hundredths, thousandths, 10,000ths. So it's actually going to round up to 0.61, and we could put 00 to get to the 10,000ths place. And there's your answer. The next two are similar. We'll do number 13 here. We'll first subtract 7 from both sides. Slide this up. And we get 12 to the n minus 5 equals 93 minus 7 is 86. Once again, you have two options here. What I would often taught is just take the log of both sides. You could do common log or natural log. I obviously choose natural log because it's less letters to write and we want to be efficient. So this n minus 5 can come out front using the power rule. And we're going to go ahead and solve for n, so we could divide by the natural log of 12. There's a couple different ways you could solve. You could distribute first, but it seems like dividing by the natural log of 12 would probably be easiest. So we have n minus 5 equals the natural log of 86 over the natural log of 12. I prefer leaving the natural logs in there. You could find the decimals here, but then you have to remember more numbers, so I just prefer doing it this way. Now the last thing we would do is add 5 to both sides. And we get n equals the natural log of 86 over the natural log of 12 plus 5. You can put that in your calculator. Natural log of 86 divided by the natural log of 12 is 1.7926. Plus 5, so obviously that's 6.7926. The other thing we could have done, I mentioned there was two ways to do this, was sorry, not from there, actually. Well, yeah, let's do that. We'll still add 7 to both sides, so we have 12 to the n minus 5. Subtract 7 from both sides gives us 86. We could actually change this to log form. This is log base 12 of 86 equals n minus 5. Some calculators you can put base 12 in, so you could do that. Or we have learned what's called the change of base formula. The change of base formula simply tells us we can change any logarithm to a logarithm with whatever base we choose. So once again, I would choose natural log. So I could do natural log of the 86 over natural log of 12. That's the change of base formula that we've learned. And then we could add 5 to both sides. And notice we get the exact same answer we had the other way. So it looks like it's a bit shorter. And there's our answer. We could put in our calculator to get that. So maybe it's not a lot shorter because there they are on the same row. Number 14, I won't finish this one out, but you would start by isolating the radical. In this case, you would have to divide by negative 3.1 to start with. And you get 15 to the negative 0.7x equals, and negative 10 divided by 3.1 is, you could actually leave it as a fraction because then it's a little easier to write out each time, in my opinion. But if you do divide it, you get 3.2258, and you could go ahead and solve from there.